Yeah, I wasn't recording yet. I was like, is this is this stuff we want or in the recording or not? So yeah, go.
Yeah. We have pushed the release candidate 2 this week, and one thing I wanted to highlight, just so everyone is aware, as part of that, we have updated the license from BSD to Apache 2. They're basically equivalent, but as part of the getting VOLTTRON into Eclipse, that was one of the requirements. I can briefly talk about some of the additions, and then I'll turn it over to Craig for anything more, and then we'll go to Kyle for the regularly scheduled program. There's been a lot of improvements to the platform since the first release candidate. Craig and everybody's been working really hard on taking feedback that we've gotten and firming things up. We've also incorporated several contributions from external and internal folks. For example, there's a new market service, which Kyle can talk about if you're interested. It basically provides a way for agents to bid on services with each other. And then there's, if you remember, we had a UI for configuring BACnet devices. That's been, there's a new version of that out that should be more reliable, and that might be a worthy topic for the next office hours to go over that again. Documentation, Craig took a good crack at the documentation and made it look a lot prettier and a lot more navigable, especially the walkthrough. So that's great.
More to come before the real 5.0.
Yeah. And then we incorporated a Kafka agent that had been contributed back. Is there anything else that you wanted to highlight as part of this, Craig?
No, basically just point to the release notes that are out there. Might be good just to put that in the chat so people can just go to it. And I guess one thing that I do want to mention is that if you have the RC branch checked out, then all you really need to do in order to update to the new stuff is do a git pull from the main VOLTTRON repository, and that will get you all the stuff. You will then need to rebuild the agents and the platform, but other than that, everything should be everything should be backward compatible.
And we've got a pull request to merge all this back into develop.
Yes, and that is waiting for your review. Which should just be a blessing, but you know.
Yeah. So, okay. Let me know if there's any questions around this. Otherwise, we'll turn it over to Kyle, and there'll be time at the end for if people want to cover anything as well.
I hope so.
Hey, Jeremy, it's Rob Calvert from Kisensen.
Hi.
Since you brought up pull requests, we have a couple of outstanding pull requests on develop, and a couple things about them. One is that the Travis PyTest build was failing for what appeared to be an unrelated reason having to do with a crate install, and I noticed that Craig's pull request got through the Travis build yesterday. Also, since Craig's pulling all the 5.0 changes back into develop, would you like for us to cancel those and resubmit the pull request on top of Craig's changes?
You could either do that, or you could simply do a pull from do a pull push thing from develop once it's in. That would be fine too. Either way.
Yeah, that'll update your pull request automatically.
Okay, after rebasing to Craig's changes. Yeah.
Well, that will rebase to Craig's changes.
So, what once the RC2 is merged into develop, if you do a pull from the main repository into your branch, then do a pushback into that same branch, it will automatically be reflected in the pull request you've already submitted.
Yeah.
Okay.
Yeah, you just basically do a pull from upstream.
Okay.
If you need help walking through that, that's very much a Git specific topic, and one of us can help you with that if you run into problems. But if you've done it correctly, then all of the changes from RC5 that get merged into develop will be then merged into your fork, and it'll update the pull request accordingly.
Hey.
Yeah, we're happy to do that. I was really more worried about that Travis failure, but I'm hoping that Greg, you were able to resolve that.
Well, the Travis is kind of a sticky wicket. There are a few things in there that fail intermittently because of race conditions, and we haven't sorted them all out. And they're not. I mean, we're always trying to deal with that just because of the nature of doing the tests. It's hard to avoid, especially given the asynchronous nature of the platform. So there are a few in there that you can do everything right, and like not all of the we test on 4 different deployments, and like 2 of them will fail, and it's probably nothing you did. So
yeah, this one's a little more serious. So the crate install, I don't know if you saw that, Craig.
Yeah, I took care of it.
Okay.
So
cool, thanks.
I will. Yeah, I took care of it.
Okay. Were you going to say something, Bora?
Yeah, Rob. Are you? I wanted to get the kind of. Are you guys still working on DMP3 support for VOLTTRON?
We are. Let Bob answer that one.
Yeah. When do you think that will be available?
I'd say we're still some months away. We are working through wrapping the Open DMP3 C++ project with Python classes. So it's I certainly no later than May, but earliest is probably March.
Well, that works for me, so thank you. I appreciate it, and I appreciate you guys doing this work with Slack and your company doing this for the project that I'm working on currently. That is something that we would really appreciate, so thank you.
Okay, and Bora, if you've got, I don't know if you're familiar with the OpenDMP3 project. It's
this is the one on GitHub, right?
It's on GitHub, and it's maintained by, I think, the team out of a company called Automatic.
Yep.
So that's what we're using, because that seems to be the most widely used. And we've used the C++ library in production for some projects that we've done, but we had not previously gone to the effort of wrapping it in Python. So that's what we're trying to do now. I think there have been attempts to do it that have sort of been abandoned in the past, but we're hoping we'll be able to do it.
Okay. All right. Well, thank you very much.
Sure.
All right. Well, I think we're ready to get started on today's primary topic. So this week we are going to continue our discussion of the VOLTTRON agent internals. And I'm going to be just basically going off of the source code on GitHub. So if you want to follow along in your own browser, most of everything in the agent core starts from that directory there that I just posted in the chat. Let's see. And the actual agent class, so I kind of skipped over this last time, and went directly into agent core, because really agent core is the driver for the agent lifecycle, and so that was appropriate. But that's not where the agent class is defined in in the VOLTTRON framework. So let me make this a little bit bigger. If anybody has trouble reading this, let me know. But I think that's about as big as I can make it. All right. So the agent class itself is defined in platform VIP agent and then in the __ init file. Now, oftentimes, this is for those of you who are not familiar with the way packages work in Python. The presence of the _ init file turns that directory into a package. Now, usually you'll see those files and they'll just be empty, but it is also possible to put stuff into that that file that can be imported like anything else. And so when Brandon was setting this up, he chose to define the agent class in the init file, which is perfectly acceptable, and is just it is a fine way to do it. So here we define the agent class, and within the agent class we define another class called subsystems, which we didn't have to define this inside the agent class, but it's a style choice that Brandon made. Like I say, it's fine. It's only used within the agent class, so it's appropriate to define it within the agent class itself. You could go either way. If I had done it, I probably would have put it outside, but it's a style choice. So this subsystems class creates all of the subsystems that the agent uses. And you'll notice that its arguments for its constructor are the owner of the class, which, as you'll see when this gets instantiated later on down in the agent class, the core, which is the instance of the core class, which is what we went over last time, and then some settings to determine how it's going to behave on startup. The core is probably the most important argument, because the various subsystems use core to communicate, or to not communicate, to do things at certain points in the agent lifecycle. For instance, the hello subsystem is the subsystem that gets used to determine whether or not the agent has successfully connected to the platform, or if there's some sort of like authentication error, the hello process will fail. Well, hello takes core as an argument, and we'll look at hello a little bit later, but what it needs core for is so that it can hook up to a specific event in the agent's lifecycle, so that it can trigger the hello process after we've established our connection to the after we've established our connection to the message bus. So same thing with pub sub. The pub sub needs to know that we've connected to the platform, so that it can go and it can submit its subscription list to the platform, so that the pub subsystem can send you the appropriate messages. Also, these are also hooking up things like, so the RPC subsystem is used by pub sub, so for some of its startup and some of the maintaining of its state. So we create the RPC subsystem, and then we pass it into pub sub, so the pub sub can do some communication with the platform. The channel subsystem is for sending streams of data. There's a particular part of, there's only one agent that uses this, and it's one of the core agents in the that's built into the platform. It's used for installing other agents But if you want to create a stream of data between agents, you can use the channel subsystem to do that. Nobody uses it because it's very special case. Although now that I'm,
it's fiddly.
And it's fiddly. Yes, it is also very fiddly. You have to basically start a channel with an RPC call, and we would have to go over an example. Unless your use case absolutely positively has to use something like that, I wouldn't even consider it because, like Craig says, it's fiddly, and there's lots of ways to mess it up. The health subsystem sits on top of RPC. That's so that agents can indicate their current status. By default, an agent is considered healthy. If something goes wrong in the agent, like you can optionally use the health subsystem to change the status of an agent and put some sort of error message or some sort of status message, which I believe then you can retrieve via VOLTTRON Central. So some of the core agents use it, and it is available for anybody who wants to use it. I think there are some of the core service agents that could take better advantage of it, such as like drivers and stuff. The master driver currently doesn't use the health subsystem, and it probably should. So then there's the heartbeat, which an agent can publish a heartbeat signal to indicate to the rest of the platform that it's alive. And then we have the config store. By default, enable store is true. So if an agent wants to use config store by default, it will use it. Although there are many agents that have no use for the config store, especially like the core service agents that are built into the platform don't use it. Or if, for example, the example I set to do like an agent from a script, that has no use for a config store, so you want to disable support for the config store, and it makes that agent start up faster as well. And if there happened to be a configuration store for this particular identity, it would want to download all those configuration, all that configuration data before it started, so we just shut it off. And if your agent isn't set up to use the config store yet, you can go ahead and set enable store to false when you call VIP main, and it will pass it through. And then later, when you add support for the config store, you can turn it back on. Same thing with enable the web subsystem. Craig could probably speak a little bit more to how the web subsystem works and what it's for. But if do you want to comment on that, Craig? Or
yeah, this by passing enable web to your on the agent startup, it will enable the client side web subsystem, and that's just about it. So that you could actually talk to the platform's website. And in order for that to actually work, the platform itself has to have been web enabled as well. So you have to have a bind IP address or a bind web address set on it in order for it to work. And
this is the mechanism that allows you to do RESTful API calls to do RPC,
yes,
right?
Exactly. Yeah. This allows you to register endpoints, register folders that can be served through HTTP, and then allows you to make RPC calls back into the platform itself.
Yeah, and you can do RESTful API calls to the RPC methods of the agent, right?
Yes.
Yeah. So if you want to, we do get this question occasionally.
That's kind of what the endpoint is, but that's okay.
Yeah. Okay, yeah. There's a few things you have to hook up, but then we get this question every now and then. It's like, I want to set up a RESTful API to my agent, and so people try and set up their own web server and run it inside the agent. It's a big hassle, whereas we already have this service that you just hook it up, and then there's a REST point on your VOLTTRON platform that you can send messages to your agent with, and do whatever you need to do, and it handles it for you. And then auth is for authorization. You usually don't work with the auth subsystem directly, but that's the subsystem that gets used to do authentication and authorization with the platform. So in our actual agent constructor, we have lots of options here. Now, a lot of these are handled via the VIP main call during a normal agent startup. You'll notice here when we are starting up the agent by hand, we are supplying the address, we are supplying an identity. If you don't supply an identity and you're not using VIP main, and we start the agent this way, it will actually create a GUID for the identity. That's the only time it'll use a GUID. Any other method that you use to start the agent will use a proper identity. And we're hooking up the authorization and authentication by hand, and we're shutting off the store. So,
did you?
Yes.
I wasn't here last time, but did
Yes.
you go through the fact that you're actually using the platform's specific key and secret key in order to make that work?
This here?
Yeah.
No, I did not.
Oh no, you're not. Never mind. I'm sorry. Yeah.
Okay.
Okay.
All right. Yeah, no, this is we just got a question about using an agent from a script, and so we didn't cover this use case last time, but we have covered it before. I have answered it before in the Slack channel, so it's good to go over. So a lot of these, most of these, you are not going to create yourself. Like, you're not going to supply the secret key or the public key or the server key. That's all going to be handled by VIP main when your agent starts up in your boilerplate for normal agent development. Although anything that you pass to VIP main can't. The stuff that you pass to VIP main can be passed through to your constructor. So we create a core. And since the core is managing the connection to the message bus, it needs the address, it needs the public key, the secret key, the server key, and the actual home. And like I say, most of the time, VIP main is just handling all of this for you. And then we create an instance of the agent subsystem object, which we then assign to the name VIP. So that's why when you are doing an RPC, call it self.vip.rpc. So then so then you're referring actually to this RPC object, which handles all of your RPC calls. So we can dig into any one of these. Let's look at hello, because hello is pretty simple. So if you go up to the parent directory and go into subsystems, these are all of the subsystem modules for an agent. And so if you want to look at specifically how any of these work and how they interact with the agent lifecycle, you can just dig into them. And note that they are created right after core is created, and they receive core as an object. So let's see, and if I recall, subsystem base is an empty class. There's not a lot in there. So let's look at subsystem base before we get in there.
Yeah, it is an empty class. It's just a way to lump them all together.
Yeah. Okay. I didn't want to say that authoritatively and be wrong. Okay. So here's our hello subsystem. It takes the core and creates a weak reference to it.
Let's before you go into this, let's go back up to the top. and let's take a look at the very first code line. And what does that do? Or I was actually talking about the we can look at the future and then the all. What is that actually doing, Kyle?
This? Okay. So this is a style choice that was made by Brandon. So in Python, let me get a console up here. And let me share this guy. Present. Okay, so I have no idea what this is looking like on your end, but you should be seeing a terminal window.
And yeah, that's good.
Okay. So in Python, when you do an import, usually you do import, let's do math. And so whenever you want to reference anything in the math module, you can do math.py. Actually, let's do tau. But you can also do a from import. So from math import tau like that. And then tau is available in the current namespace, and you don't have to qualify it with math.tau. Well, you can also do from math import star. And what that does is that takes everything that's in math and imports it into the current namespace. So now I have pi, I have the cosine function, everything that was in math is now available in the current namespace. Generally, this is considered most useful for when I'm working with the Python command line interpreter. It is sometimes considered bad form to use it in your code, because then everything that was in the math namespace is now in the current namespace, and sometimes that can be like lots of stuff, and you might end up accidentally bringing things into the namespace that you didn't intend to, and then you'll create a variable name that stomps on that variable name. And so generally, what you want to do is something like this, and you want to call out all of the variables from math explicitly that you want in the current namespace. Well, what the all double underscore all does is you can assign that to a list, and then if somebody does the star import, like I've done here, it will only import the things into the current namespace that are listed in all. And this becomes useful if you want to, because normally if I did from hello import all import star, I would get 0mq from 0mq, because this is in the namespace in hello.py. So is let's see, e not sock, or that error. All of those would also get imported into the namespace, as well as the hello class. Logging would get imported because they're all in hello's global namespace. This says if somebody does a star import against this module, only import the thing with this name. And in this case, it's the hello class. And so then in our init, let's see, so from import hello. Oh, yeah. And then we have an all import in our, oh, I forgot we're in subsystems. We have our all import is import peerless ping RPC hello pub sub channel. So it does all of that in all. And then if we come up one level and we come to our and come to this file, then we can do from .core import star, from subsystems import star, and we don't have to qualify everything. And that's a style choice. You could do it either way. You could actually not specify the all imports, and then in like from subsystems import hello import, So that what he's doing here is, instead of going from .subsystems.hello import the hello class. He's just doing from subsystems import star, and then he's got the all list set up so that it just gives him the actual class from each subsystem directly. So this is getting the hello class from the subsystems import. Again, it's a style. It's a style choice, and it does kind of obfuscate where these classes are coming from a little bit, but it's not something that other people are going to use directly, so it's less of an issue. Although it does make it hard for people who are not familiar with this code to make sense of what it's actually doing. So that's what's going on there.
Hey, Kyle.
Yes.
I have a follow-up question on that.
Sure.
So you mentioned style choices. So have you guys had any discussions internally about conforming to some style guide standard? And I'm thinking of things like some of the things we internally do, like conforming to PEP 8.
Yeah, so we do conform not strictly to PEP 8 because there's
loosely to PEP 8.
Loosely to PEP 8. Like we don't necessarily respect the 80 character limit. I think we push it out to 120 because 80 characters can get kind of arduous. But we follow the naming conventions, trying to use underscore variable names when we should. The way we name classes and variable and function names and variable names, we generally follow PEP 8 pretty well.
But you don't have a statement somewhere to the effect that this, if you want to contribute to this project, these are the standards to follow.
So that's one of the things that's coming. There's actually one of the things that went into the pull request into the RC branch is a template for our issues and for pull requests, and in that template there is I believe a statement of that. But there does need to be a wider array of out on Read the Docs about exactly what is required in order to get things passed.
Yeah. Okay. All right. We got to talk about it. That's good.
Yeah. We're headed there.
Star doesn't pass a code review internally because we don't allow it.
Yeah.
And there's a bunch of things like that are kind of not PEP 8 necessarily, but like we also sort of pick and choose from the Google style guide.
Yeah.
For Python.
Well, and the thing is, so Lars Kohn, he's an engineer for Mozilla. He makes the point is that you have to be careful with style guides because when you're doing code reviews, it's demonstrated. I don't know how there's been research done that suggests that having a strict style guide kind of gets people to focus on style points that are kind of superfluous and less focused on how the code is doing what it's doing and whether or not it's the best way to do it. And there is some truth to that. I mean, when I review code, I try and, it's like, yeah, okay, this style, you need to fix the style, but then after that I just ignore it and I'm more concerned about are you taking advantage of the way Python works to solve this problem in an elegant way? Are you, or does your code look like, you have more experience with C and so you're doing things in more of the way of a C programmer would, and you're not taking advantage, and it's making for code that's not as clean as it could be. Stuff. We try and be more concerned about that, and that's generally a bigger issue than strictly conforming to PEP 8. But
the other thing, I'm sorry, Kyle, I'm cutting you off a little bit, but is consistency. When you get an agent, right, and somebody's committing an agent to the repository, is that core package consistent in its style? If things can be snake case, they can be camel case, whatever, but the whole thing needs to be that way rather than flip-flopping back and forth and stuff like that.
Right. And then there are other things too that and there's stuff that we need to address in the code that's like it's a really low priority. It's how do like core agents go about setting up certain things. Like we still have agents that use the closure style for handling configuration. And
not too much anymore, but
not too much. We've worked through most of them. But there are still examples that use it, and that's not the way. And especially if you want to use the config store, or actually, most importantly, if you want your agent to have its doc strings automatically ingested by the Sphinx, you can't do that, and that's a big part of the reason that we're moving away from it. And there are some other reasons as well. And so that's like, but that's not. That's not covered in a style guide anywhere. That's not covered by PEP 8, but it's a style as far as like how agents are, how you go about solving certain problems. There's standard best practice ways to do those, and we could try and write a style guide, but that style guide's always going to be in flux. The best style guide we have is implementing our own stuff that way, and we're getting better.
We're definitely off the rails.
We are way off the rails.
Yeah, I'm not suggesting anything extreme, and right. I mean, there's a process I think a team goes through, and it's a little harder with the distributed community probably. But
sure.
Yes.
So we have certain things that we kind of all have come to a consensus on, like import star, don't do that. Right. Things that.
Yeah.
And I guess as a community, I mean, you're talking about those kind of things as well. Mm-hmm. It would be helpful to document some of those core things, just the minimal set of things, Right. I mean, another thing would be
that would be really. I would be interested in seeing your vision on this. If you could write something up and throw it in the documentation, that would be absolutely fabulous. We could take a look at it, comment on it, and bless it.
Yeah. So the other thing is like there are other ways. So this kinds of style stuff that I'm talking about is as we move forward with things like the agent templates, that for which we already have a standard agent template. The most important thing we can do is a style guide for the stuff that I talked about for how to solve certain problems that are common agent problems with like dealing with your configuration and stuff. The loudest way that we can emphasize those is that our agent template does the code that it produces for you does it the way that we would expect it to be done. And there are more of those templates to come. For instance, I should probably get started on the historian agent template because we've made the changes to the base historian now that we can actually establish some best practices for developing historian agents, whereas before there really wasn't best practices because it was kind of in flux.
Oh, that's interesting. Let me ask you about that because we're actually well into development of a InfluxDB historian that we're going to contribute.
Awesome. I've been thinking about that.
The approach that we've taken has been, and the direction I've given developers is, well, go and look at, make sure you understand base historian, obviously.
Yeah.
But then also look at some other historians. Look at Mongo or look at Crate or look at SQL historian, and make sure you understand what they're doing and why, and follow those patterns that you see in that code.
Right.
Unless you see something that just seems wrong, and then let's talk about it and try to figure what's going on.
Okay. So
yeah.
Oh, so what I was
something we should be focusing
on. Well, so a few things changed. One is that there were features that were in specific historians. That functionality has moved into the base historian, and all of that is in the release candidate. So if I'm not sure which version of the base historian you were looking at, but if you look at the one as it currently stands in the release candidate, that's got now a complete set of features that will now be common to all historians because it's in the base historian.
Okay. Has that been in develop? Because we've been working on.
Yes, that's been in develop for a while.
Okay. Thank you, Craig. I couldn't remember
Yeah,
where.
that was in when the release candidate first came out,
Okay.
and that has long since been in develop.
Good.
Yeah.
Okay. Yeah, I think we've noticed like we're implementing some of the aggregate queries stuff now, and
Yep.
we're following
Yep.
what's
Yep.
in base historian. And yeah. Okay.
Yeah. Okay. So that was one thing. So then there's like then you should be looking at them for examples of using the config store, because the config store support has been added to all the historians.
Yep, we're doing that.
Okay, so you'll have good examples as to how to integrate config store support, because there's stuff now, and that was one of the important things that got added into the base historian was making config store support possible, because the old lifecycle before config store support wasn't really conducive of you changing your configuration, and now there's functions that you can implement in your historian implementation for automatically recreating your connection when your connection settings have changed, and it'll do that stuff for you automatically.
Yep. Okay.
Okay. So yeah. So
following all that.
yeah. Okay. So then you're good.
Config store though, since you mentioned
hold on. Let's get back to the hello and that, and we'll talk about
you're right. Okay.
this stuff after the fact. Okay.
45 minutes into the meeting.
Yeah.
It's great. No, I love it. This is all good stuff. Okay. So the hello subsystem, the core thing that it does is it registers a let's see. Now I'm trying to remember what core register does, and I might have to go look. But we handle the so we're registering to handle hello messages for VIP, and we're handling the hello and the error. Let's see, somewhere in here. Let's see. So we have handle hello, and then we have hello. Let's see.
So hello, I believe, is going to be that's the method that's going to be called on the way back.
Yeah.
And then the handler for hello, and then the handle for errors.
Yeah. Well, the one thing. Yeah. And the other thing is that this register, I believe, sets this up to be called after we've successfully connected to the platform. In fact, let's go look real quick. So if we go into core, need to go up one more. We go into core. Okay. Oh yeah, so we're registering a handler. We're giving it a name. We're passing the handler function, and then the error handler. If the error handler is supplied, then we go ahead and connect that up to on error. And the subsystems. So when a VIP message comes in, part of the message is what subsystem the particular message is for, and it calls the appropriate subsystem. When a message of that type comes in. So that's kind of a general how subsystems are hooked up. So if we come back in here to hello, we also have a hello call. So this is if an agent wants to call hello manually, this is the method that actually gets called. But when we handle a hello message, we do it with the hello handler. So, and this is this kind of gets into the weeds as to how VIP actually works, because this is now taking the raw message off of the message bus and breaking it into pieces. It's a It's either a hello message or a welcome message, and this is basically once it's connected to the platform, it sends a hello. It sends a hello to the platform. Then the platform replies with a welcome, and so there's actually an agent running on the actual platform that receives these hello messages and returns the welcome response. Let's see. The one thing that I was hoping to point out, and then we can also manually call a hello if we want to. The one thing I was hoping to point out is where we hook up to the event in the subsystem later on in the life cycle, because we have to trigger an initial hello message to establish that we've connected to the platform. And I think core actually triggers this one manually. So let's look. Hello. Let's see. All right. So yeah, okay. So this, so the hello subsystem is not used as part of the startup. We actually send the hello message manually in core, but we can receive hello messages. Any agent can receive a hello message and then send a welcome response. In this case, we're sending a hello message to the router itself, and the router has a handler for hello messages, and so there's not another agent on the platform that it routes to, and then the router just responds with a welcome, and then we set an event that waits, that gets triggered by the hello response. So we set up the hello response that will get called when the response to our hello message returns, and then we trigger the hello response event, which says, okay, we've started successfully. We have a connection to the platform. Everything's copacetic. We can continue. We call our on start. This is where the on start event gets triggered. So all the on start methods that are hooked up in our agent get called, and then we call our on starts. We call all of we call the configuration event, which handles the config subsystem, and then if there's a running event, which if we come back here to install this this event that we pass into the run core method, and we wait on it, that is the same event. So this event right here that gets triggered on the return of our hello response, that gets triggered. Oh, dang it. Lost my spot here. That gets triggered, and then in this case, this will unblock. So that's where that's actually happening. Okay. So maybe the hello subsystem was not a good example here, because there are other. Let's see. Let's look at peer list, because if I recall, peer list is pretty simple. Yeah. Okay, so peer list, the setup is similar to our hello. We hook up to our core. We keep a reference to it. We register ourself as a subsystem, and then we have an on add and on drop.
Hey, Kyle?
Yes.
What is peer list? What is peer list for?
So peer list is any agent can get a list of VIP identities of all the other peers that are available on the platform.
Ah, okay.
Yeah.
Well, specifically that service, like a simple service, just gives you back a list of all the.
Yeah, it gives you back a list of all the identities. It's used a lot on the platform side, like VOLTTRON Central uses it a lot. In some cases, like the forward historian uses it to verify that a particular peer is running before it forwards, before it publishes stuff on the pub sub on the remote platform, things like that. If you are looking for a particular set of peers, you can use that. If you have a naming convention for VIP identities for particular peers, you could, but it's dynamic. You could grab the peer list and go through it and say, okay, these are all the lists with this particular prefix, and so I want to do particular things with them. You could use the peer list to do that. But mostly we use it for platform management. So yeah, and then as the peer list changes, the platform will send out the new list of peers to all of the agents and just keeps it up to date. So you'll see that there's this peer list subsystem whenever we get a peer list call, a peer list update from the platform, we handle the subsystem and just basically updates our local copy of the peer list. So let's see. This one doesn't do it either. Now, there's probably something in the list of subsystems. In fact, we'll go back and look at that here in a little bit. So same thing. We're handling the subsystem. We're actually breaking apart the message directly, handling errors. I was under the so we might be handling the peer list subsystem too. I know that there are examples in here. Let's look at PubSub of subsystems hooking up on start methods. Let's see. There must be. Maybe I'm misunderstanding how that mechanism works.
I believe the web does, but I'm not sure.
Yeah. Well, because we're doing all these registering. Okay, so we have setup. Oh, here we go. So here is an example of it. So we have this. This is what I was expecting to see in peer list, and maybe it was in there and I just missed it. Let me go back and look real quick, and then we'll go back to PubSub.
I don't think peer list needs it.
Yeah. On add, on drop. It might be something that core handles itself. So we can look at that real quick. Okay, so for instance, subsystem there's a lot of moving parts in PubSub, especially managing subscriptions, keeping the platform PubSub subsystem up to date with what its subscriptions are, things like that. But so one of the things it needs to do is it needs to do some bookkeeping after we've successfully connected to the platform, and so we create this setup call, and we hook it up to on setup, and so that tells core, well, it adds something to the list of on setup functions that are tied to the on setup event. So when core triggers the on setup event, our setup method gets called, and then this goes through, and this is the handler. It does two things. One is it hooks up to the on connected event, and to call the connected callback. So this method down here will get triggered once we're actually connected to the message bus. But this down here is called on the on setup phase, and this goes through and handles all of the decorators for. So if you have a decorator, if you've used the PubSub decorator to decorate a function to subscribe to a particular topic, and it's not in any way dynamic, this is what goes through and processes all all of those processes, all of the things that were set up by the decorator. So this is some inside baseball here. This is how that works. And in addition to that, it also does the sets up the on connected event so that when we are connected, we synchronize our subscriptions with the platform. All right. Thanks for coming, Bob. Okay. So that's kind of a general overview of how subsystems work. They follow the same general pattern. Config store, we're not going to get bogged down in it because it's very complicated. But it's
one more question, Kyle.
Sure.
When you use the @core decorator, that's operating on the same premise as the @core setup decorator. That's
Yes.
operating on the same premise as the connect, or
Right.
not connect, but the on.
The on connect call. So the subsystems are connecting to the on connect and the on start events manually, but that's essentially what the decorator is doing, is hooking up to those events.
In a regular agent.
In a regular agent. You wouldn't do it by hand the way that subsystems do it, because there's like an order of execution. Things need to happen in a certain order. It's just easier for the subsystems to do it by hand. But it's not the way that we would recommend doing it. So, and they're doing things like we are setting up, like here in config store, Craig, we're setting up things like when you export a method for RPC, you use the decorator for that. Subsystems have to go in and use the RPC subsystem directly to hook up their callbacks. For instance, the config store does its communication with the platform via RPC, and this is where we set up those methods. Now, the interesting thing here is that when you set up an RPC method manually, you can do things like give it a name that is not a valid method name. So here's the update config method, which is what actually gets called. Here's the name that we give it, which has a dot in it, which you can't put in a normal method name. So you couldn't have if you wanted to have a dot in your RPC method name, you would have to hook it up by hand like this. So that's just a little fun fact. And then we do something similar. We have an on setup, and then we have an on configuration, which happens after on start. And that's done. That's done in that order on purpose. So yeah, the config store is very complicated because it's doing things like when you reference in a configuration in the config store, if you reference one configuration from another, all of that's hooked up on the client side, and that's what all of this is managing that and hooking it up and making sure that everything is presented to the agent in a logical way, and that order of execution is preserved. There's lots going on in there. That was quite the test to make that work. So, but at the top level, it's still following the same basic patterns. It has some stuff it does during setup. It's hooking up some RPC calls, and it's setting up the initial state. So, for instance, here the event on the configuration event we call onConfig, which does, among other things, reaches out to the config store on the platform and gets its configurations, and then hooks up all the references and sets up the initial state of the configuration store from the agent's point of view. So yeah, well, we've been going for an hour already. Are there any questions about this? Is there anything in particular that you want me to cover about the subsystems? If we want to cover like the functionality of a specific subsystem, that might be a good topic for another office hours. So if we want to discuss, like, say, the health subsystem, or we've covered the config store and how to use it a couple of times. But let's see, we could do heartbeat. Peer list is as simple as I made it sound. PubSub is, most people know how to use that. RPC, most everybody knows how to use RPC, but we can cover some of these other subsystems in detail in another office hours. So, yeah. Any questions? Okay. So let's see. Rob, did you have more questions that were
no more at this time, but thanks. This has been very informative and helpful.
Okay. So there was we cut someone off. Who did we cut off? Because we were off track, and there were more questions on that tangent, and I just wanted to make sure they got addressed before we wrapped it up. But if there isn't anything, we can call it a meeting.
Yeah, I think it was Bob that got cut off, and since he had to leave anyway.
Okay. It was
just abandoned that.
Bob and Rob. And again, I'm getting you guys confused again. I'm sorry. Okay, cool. Yeah. All right. Yeah, and we try and document this stuff as much as possible, but there are new features that we put in that don't always get widely advertised. And so going over the guts of how agents work is good for the community, I think. So, okay. Yeah. If there isn't anything else, we'll call it a meeting. And thanks for coming. And like you say, for the foreseeable future, we'll probably be using this same meeting space so we can continue to record. It might become the new permanent meeting, which means that everybody will have to receive a new invite, and we'll have to go through that whole process again. But like Jeremy said, it's a good chance to purge the invite list for people who are not actually interested in the office hours anymore. So anyway, thanks for coming, everybody, and we'll see you in 2 weeks.